I am from Kitware. We're an open source scientific computing company, and I'm going to be talking about this new tool that was just released not too long ago. A disclaimer, I did not write the tool. I don't think I have one patch within the tool, but I'm just the messenger. The person who actually did all the work is Brad King. He's one of my colleagues at Kitware. Helps them Bill Hoffman. And then we have a community member, Michka Poff, who's been really helpful in making stuff actually work and happen. So we're going to talk about this new tool. It's exciting and interesting, and hopefully it'll have some value for you. We'll not just talk about the tool, but kind of Python wrapping in general, and how it works, why this is important, and how it solves part of the problem. Start with the motivation of what we built it for, and then give a little description, and then how you use it within scientific Python. So the motivation and history, it started by wrapping the Insight toolkit. So this is one of my favorite open source projects because I work a lot on it. It's started a long time ago in 1999 by the US National Institutes of Health. The National Library of Medicine, they did a big project where they imaged two people, their full body in many different imaging modalities, and they called it the Visible Human Project. And there's a large amount of data, but they needed some software to actually analyze it and use it. So they started a software toolkit, and then this toolkit can do many complicated analysis, helpful analysis for doing tasks like segmentation, identifying different structures within images, or registering two different images that are different modalities or taken at different time points and determining the spatial transformation between them. So this is a large project, and it's written primarily in C++, like many. And so it's grown since 1999. It's 1.6 million lines of code, and it's highly templated C++. So a big, large code base, and it's C++, which does have some advantages, but really if you want to use it practically, we want to use Python, and we don't want to kind of rewrite the whole toolkit, but so we have to do wrapping of the C or C++. And this is one of the projects that got started on the side that was kind of absorbed into the main line. The little logo down there says, the most efficient way of wrapping a big library is eating it. I'm not sure where the Cheshire Cat comes from, but. So in general, if you're wrapping something into Python, you have these different tasks that you have to complete. Most of the time, especially if it's a large library and you don't want to, again, write the C++ again, you want to do everything automated as much as possible. So in our case, what we do is we have to determine an abstract syntax tree from the C++ sources. So we have to know what code is actually there. And then the other steps in ITK, for example, that we use, we create swig.i files from the abstract syntax tree, and also decide how we want to instantiate the templates, and then generate CPython extension code from swig, and then build it. That's kind of a section of the practical steps that you have to do. So this project, it really helps with this one step here, which can be quite a tricky one in practice, and that's determining the abstract syntax tree. So how do you figure out what the abstract syntax tree is from your C++ sources? We have on the left maybe a little bit of the C++ source code that you're going to build into a translation unit, and then you want some representation of what's actually there in a programmatic form. Here it's encoded in XML so that you can process it and use it. So it seems pretty simple. You have the raw sources, and we just want a workable, usable representation of it. And so you take the raw sources, and there is a processing and a parsing step that has to happen, and then you have your abstract syntax tree. In practice, because of C and C++ and the history of how it works, this processing stage can be a little convoluted. In fact, I'm not sure if David Bowie is involved in a labyrinth, but it can be pretty complex sometimes. So to get an idea of kind of what's happening, here we'll use a little metaphor on baking cookies, which is fun, which I like to do. And so the idea is, the metaphor is you're starting off with the C++ code, your ingredients, and as part of the step of baking the cookies, you process the ingredients, and so that you can make the abstract syntax tree, which either you compile down to machine code or you wrap it, put nice, delicious frosting on it so you can use it from Python. And so what is this process of generating the abstract syntax tree? Well, you don't go immediately from ingredients to a baked cookie, right? We have that processing in between, and what happens when C++ code is processed? First, it goes to the C preprocessor, right? And so you have your source code, but that's not what actually goes into the parser. So you have these pound defines, pound includes, and they can actually change what your source code is in an arbitrary way by changing string values. And then also in this processing step, you're pound including some of the standard library headers. And in practice, they're not all made the same. Their implementation is different, and between compilers, you'll get a different result for the abstract syntax tree based on what compiler you're using. And on top of that, you also, whenever you compile something, you add some compiler flags, and then those also affect the resulting abstract syntax tree in practice. So what you end up with is it's not very uniform. It's not always Little Debbie. This is an ugly-looking gingerbread man that I might make. But you have to be able to realize that the abstract syntax tree between compilers is different, and if you want to wrap the right thing, you're going to have to take this whole process and, one approach maybe to emulate and try to reproduce this whole pre-processing and then simulate the different standard library compiler headers and then make sure you have the right compiler flags. But that would be very hard, right? That would be very, very difficult and a lot of work to try to exactly reproduce that. So the approach that was taken was then just to reuse that whole set of processes and just use what's exactly there and then take the output after that stage. So there was an earlier project before we get to CastXML called GCCXML, and this was developed again for wrapping the Insight toolkit, and this will take and do the C preprocessing on your sources, and it also, in addition to GCC, it would patch in headers from Microsoft Visual Studio so that you could simulate the standard library headers of the target compiler, and you'd also pass in the same compiler flags so you get the exact same result. And C++ is a notoriously very complex and difficult language to try to parse. So you just reuse all the work that's in there in GCC, C++ parsing capability. And the output you'd get would then be an XML representation of the abstract syntax tree instead of compiling to code. And then you take that and do what you need to it for the next steps. So that was GCC XML, and it's been out there for quite a while, and we used it for IDK in kind of the customized wrapping process we have, but there's also other projects that took it up and used it for more general wrapping. Other projects based on Boost Python, use it as for the parsing step, Python C-types lib, and XStress, cross-stress, and then there's other ways it's been used for things where you need to get that abstract syntax tree, other than wrapping too. It's very useful. So it's very good project, very useful. So why are we talking about GCC XML? Well, software, for it to be useful, has to keep working, and it's always evolving, and it has to be sustainable, and GCC XML had this practical problem that it was a lot of work to maintain. Just kind of the way you're sort of forking GCC, in a sense, and bringing in these system headers made it hard to maintain. So along comes LLVM clang, and so CastXML is a little acronym standing for a C family abstract syntax tree XML output tool. And instead of using GCC, it works in conjunction with clang. So very similar, does the same thing, and it will work with C++ compiler that has C++11 support, so Microsoft Visual Studio and GCC and clang. And you build it with CMake, and then you build against LLVM clang. You need 3.6.0 or later. It's a newer project. Right now, there's some kind of patches getting upstream, so it will be easier to build in the future, I think, and hopefully we'll have binaries, etc. But for now, you have to build LLVM and clang 2 from source, which is a long build, but you can get it to work, and install those into install prefix, and then build CastXML against that. And then it's very simple to use. It's a command line executable, and right now it just outputs GCC XML compatible output XML file. And you can also specify the compiler you're trying to simulate, and then you put in the translation unit. You can also add to here flags that you're using to when you do compile the source code. And that's very simple. That's what it is. And so it's not a full wrapping tool. You have to add other parts to the wrapping process. It's just this abstract syntax tree generator, and then you can choose whatever other wrapping tool you'd like to. Or you can just look at the output. Instead of looking at the XML output, there's a project out there called PyGCCXML. And then this project has been updated to not only process GCC XML output, but now CastXML. And so it gives you kind of better data structures to work with than just the raw XML. And this project's been around for a while, from 2004, and multiple people forked it, tried to add Python 3 support, but recently, one of these very nice community members came from the community and started maintaining it, updating it, revived it, adding the Python 3 support, and getting it working with CastXML. So things that have happened with it, it's moved to Git, and also working with all the other current Python, CPython implementations, and getting good code coverage, getting good documentation, getting good code structure, and making it PEP8. So it's kind of been cleaned up and alive. So typically what you'd have here, if you want to try using it, is you have your input on the left, and then you write a little bit of Python code on the right, and then it gives you out some nice data structures that give you the different structures within the C++ code that you can process. And so it's still being updated to the latest CastXML. There's some unit tests that are still failing, but there are unit tests, and it's being checked and worked on, so it's in a mostly usable state at this point. In summary, we have the wrapping process has this abstract syntax tree that you have to get, and it's an important part of the wrapping process. And if you want to create this abstract syntax tree correctly, you have to understand the compiler-dependent stages, like the C preprocessor and the standard library headers. And so there's a new tool out there that you can use that should be very helpful called CastXML that completely emulates or uses this whole process, reuses this whole process, so you get a good abstract syntax tree for correct Python wrappers. And if you want to use it from Python, use PyGCCXML. And watch out for David Bowie, because he's not so helpful sometimes. And here are the mailing lists. Here are the resources for the project. We have a Mailman mailing list and a GitHub repository. So please become involved. We welcome involvement. Are there any questions? The whole stack of doing the wrapping process. So this is one component of it, is getting the abstract syntax tree. Building it is what CMake would do for you, to actually run the build and build the Python modules. But then you'd want to use something like some of these other tools to give you the other parts of the process. So there's a lot of packages out there. I'm not sure which one is kind of a complete packaged. Here you go. Here's your wrappers from your C++ code. Xstress is kind of one of the most promising ones out there, I think. So take a look at that if you're just interested in wrapping your code. Okay, thank you.